What's going on, ladies and gentlemen? In this video we're going to be going over how to create a stack in Python. So what is a stack? A stack is a data structure that stores items in a last in first out manner, usually referred to as a LIFO data structure. Now I like to think of a stack like Pringles, or if you ever had chips that are stacked on top of each other. Pringles is just a good example that I could think of. But how you can see Pringles placed is the first chip is at the bottom of the Pringles bottle, and the last chip is at the top, obviously. But the first chip that you get is off the top, so you always get the last in and then the first out. So that's how I like to think of it. I like to think of it as a stack of chips, stack of Pringles, and I don't mind thinking about Pringles here and there. So if that helps you, you can use that example. And now let's start to create an implementation using Python. Alright, so I'm using VS Code as my editor, but you can use anything that you want. I created a file called stack.py, and now we should be ready to go. So to create a stack, I'm just going to create a class called stack, and this is where we're going to put our methods that a stack needs for it to be a stack. So first I'm just going to initialize a list that's going to hold the information that we're going to need for the stack. So let's make a init, and let's take that out, and we're going to define a inner stack, and this is going to be an empty list initially. A cool thing we probably could have done is, if maybe you want to restrict the capacity of the stack, you can have that provided as a parameter. If you wanted to, when a person creates the stack, they have to provide the capacity. But in this case, we're just gonna keep it simple, and we're just gonna make it as open as possible. But just if you want to make it more complex, you can do that as well. So now we have a empty list that we're gonna use to hold pretty much our chips, like we talked about. As as a Pringles bottle, every individual chip is gonna be stored in this list. And the reason why we're using a list is because a list in Python comes with amazing predefined methods like append, or if you want to take it off the top, we can just use a -1 to get the topmost value. And we're going to go over that as we start defining the methods. So the first method I want to create is the push. So with a stack, you're able to push items onto the stack. So that just means that you're inserting an item onto the stack, but you're placing it. If there's a value already in the stack, you're placing it on top of the previous value. Or if it's the first item in the stack, then you're pushing that value, or you're inserting that value to create a stack. So let's create that. We're going to define a push, and then we're going to have a parameter of self, just so that you're taking an instance of self, and then we're going to pass in what we want to push onto the stack, which is the value. Then now what we got to do is just self, because the instance of our self, or in this case the stack, and we're trying to get that variable that we created, which is the list, self.stack. And then, like I said, a list becomes with predefined methods that we can take advantage of, and in this case we want to append a value because we want to add that to the last, on top of the last value. So say for instance it was 1, and then it was 2, then now we want to append it to make it 3. We don't want to place it before the 1, we want to place it after the 2, because 2 was the last item before, but now we're adding something on top, and we make that a comment. But just to show, this is just going to be the new value appended. So in this case, we know that whenever someone calls push for the instance of the stack that they created, we want to push that value that they defined as a parameter. Cool. Another thing that a stack comes with is top. We want to see, is there currently a top value on top of the stack? Like if there's 5, or if there's 5 items, or in this case if there's 2 items, what's the topmost value? What's the topmost chip looking like in the Pringles bottle? So we can define a method called top, and we'll just have an instance of itself, but we're not taking anything as a parameter. We just want to return the topmost value in the stack. So first we got to even check, does this stack even have any values? Because you don't want to just, take something off the top and there's nothing there. So first we're going to check first if there is even anything inside of the actual stack. So we're going to do self.stack, the length of self.stack, and check if it's greater than 0. If it is, then we can just return self.stack. And another cool thing with list in Python is if we define -1 as the index, then it's just going to return the topmost or the last value in that list. So that makes our life easier. And if not, then I'm just going to choose to return -1. But in this case, you could probably choose, depending on what type of stack you make, like if it's if you want a stack of strings or stack of ints, stack of whatever, you can change that up to whatever value that you want to make sure to let the user know that this is a value that I'm going to return when there's nothing in that stack. In this case, I'm defining it as -1, but that's something that you have to think about of what you want to return back to the user if you want to let the user know there's no values in that stack. Now, the next one is how to remove off of the stack. And in this case, for a stack, we want to use pop. Pop whatever is on top out of the stack. So we're going to have to define a pop method, get the instance of self like we did before. And now, there's no extra parameter. We're just going to make sure that, just like with top, we got to make sure that we can actually take something out of the stack. So we got to make sure that, there actually is something in the stack. So we're just going to take that length again, do self.stack, and if it's greater than 0. We could also we could have utilized top here, like if the topmost value is not equal to -1, we could have did that too. Then we could just pop it off, but in this case I'm just going to use the length one, but that's also an option. So if we're able to see that there's more than 0 items in that stack, then we'll just return self.stack, and another method that the list provides is pop. Look at that, look at Python. And by default, it just removes the last item in that list. I know Python also lets you put in the index that you want to pop out of there, but by default, if you don't place anything inside of this pop method for the list, then it's just going to take the last most value. And you can actually read on to that, but yeah, default is the last. And if we're not able to pop anything out, then we're just going to return -1 again. And then that's pretty much it. Like, that's push. There's getting the topmost value, and then there's also the pop. But I also want to see, just for clarity, what's everything in the stack. And this is just going to be a helper function. This is not really what a stack comes with. Usually what you would have to do is that you would just have to pop everything out. Now obviously that'll make everything reverse, but just to show that this implementation is working, I'm going to cheat a little bit and just print everything out. But we're going to define like a print stack method, and just iterate through the list and print out what's in the stack. And just like how we've been doing before, I'm just going to just copy this whole line. And like I said before, you can also just check if there's a top value. If there isn't, then that means it's empty. But I'm just going to use the length one. And if actually, I'm going to do one check at first. First, if the length, actually no, we could do an else here, but we'll define that after. So for item in self.stack, we're just going to iterate through it. We're just going to print out the item, and we're just going to make sure in between we got some space. And else, that means that stack is equal to 0. So we're just going to print out stack is empty. So cool, we defined everything we needed to define. We got the we created this stack class. We defined initially the stack with as an empty list. Then we define the push method, which is just gonna append the value onto the stack. Then we created a method that will get the topmost value on top of the stack, so the topmost chip, as we use like Pringles. And if there is no values in the stack, then it's gonna return -1. If then we have another method called pop, which is just gonna delete the topmost value off the stack, because stack is a LIFO, last in first out. And then you got the print stack, which is just gonna be a helpful function for me, just to show you guys what's exactly in the stack as we initialize the stack really quick. So let's create a stack instance and make a stack object. And sorry for not closing this, I just realized that it was open. Hopefully you guys were able to see the implementation while I was doing it, but create an instance of a stack and then stack dot, and then you'll be able to see what's inside. Obviously you probably make that private, but we need these methods. So let's do a push, and let's push out, or let's push in 1. Let's do another push of 2, and let's do another push of 3. But wait up, let me just print that out. Actually, let me pop one out just to show you guys. Alright, and then let me do a stack dot top, just see if did it actually pop that value out. And then let's do a stack dot push to push in 4. And then after all of that, we're just gonna print that out to see how is the stack looking. Remember, like, this print is not usually in a stack. Like, usually it's you have to pop everything out and see it. But just to show you guys that everything was pushed in and everything is working well, I have that just for debugging and just for showing. But usually it's pop, top, and push for a stack. Or if you're gonna use this print stack, then you'll pop everything out and maybe insert it back in or push it back in. But let's do a Python, and then let me save it, and then do stack, and let me just do a print after, just to make sure everything's on the one line. Alright, cool. So we got 1, 2, and 4 as expected. And we forgot to print out here top, because we're getting the topmost value, but we're not actually printing it out to the console, so we're not able to see it. So in this case, we see we're pushing 1, we're pushing 2, we're pushing 3, we're popped out 3, and then we're printing out the top, which in this case we expect to see 2 because that's the topmost value, right? And then we pushed in 4, and now we want to see how the stack is looking, just for debugging case, just to show you guys that everything is working well. And you should see 1, 2, and 4 because we popped out the 3 and we pushed into 4. So everything seems to be working, and that's a stack, man. It's really useful. And as you guys start to get deeper and deeper, like, you see how useful it is. If you want to keep your data in a stacked manner, and as you start to go into like tree traversals, like DFS, which is gonna a stack is pretty important. And keeping track of the data as it comes in, this is pretty important. And you don't have to create this object every time. There's already libraries for that. Like, there's the collections.dq library for it. But just to know how it's working and how it's done, it's important. So this is how you create a stack in Python.